Okay, consider this. If you took a 1 meter by 1 meter sliver of the atmosphere, (1 meter squared column of air from the ground all the way to the top of the atmosphere, how much pressure does the weight of all that air put on the ground below? That's what we want to figure out. First we need to figure out the weight of that air column. If we're told that the mass of that column of air is 10 to the 4th kilograms, and we know the acceleration due to gravity is 10 meters per second squared, which is a rough approximation because this value would actually change as you go farther and farther away from the Earth. But nonetheless, keeping it simple, this would tell us the weight of that air column would be about 10 to the 5th newtons. Yes? And then if you calculated the pressure on the ground below, the pressure would be equal to force divided by area. So this much force, this much weight, 10 to the 5th, would be put on the 1 meter squared, and that would give us a pressure of 1 times 10 to the 5th pascals. Not only does the air exert this much pressure on the ground below, it exerts this same pressure on all objects on the ground. This is known as atmospheric pressure. And it's also called 1 atm, 1 atmosphere. We are going to be using pascals, 1 times 10 to the 5th pascals. In English units, it's equal to 15 pounds per square inch. So that means 15 pounds of force is exerted on every square inch of your body due to the air pushing up against it. It's quite amazing if you think about it. Okay, check this out, folks. The deeper you go, the more air you have on top of you. The greater the pressure. So down here at the bottom of the ocean of air, (101 kilopascals. Remember we were just talking about the 1 times 10 to the 5th pascals? Well, it's actually 1.01 times 10 to the 5th pascals. And notice if you went a little bit higher, like where this plane is flying, not as quite as much pressure. And if you went to the top of Mount Everest, the pressure drops down to 31 kilopascals. And if you went to the top of the atmosphere, the pressure would be 0 kilopascals. Oh well, I think I remember that's about 100,000 meters high. But I don't think there's like a definitive boundary between the atmosphere and where there isn't an atmosphere. I think that's about like 62 miles. The thing about atmospheric pressure, it's not just a downward pressure. You know, when you're standing down here, you have a pressure acting in all directions. It's like multi-dimensional. So basically, ladies and gentlemen, if you looked at this tube inside, this little cube here inside the tire, basically the air would be pushing on every single face of that cube. Pressure doesn't just have like one direction. It's not just like down like gravity. Okay, pressure is not a vector quantity.